Okay, so it is anticipated that the warfare is going to be unmanned, indirect, and technology driven. We all agree, I think, here. And there were a couple of books which have been published, very popular books, War of None and the Four Battlegrounds, which actually beautifully defines how the future warfare is going to be, defining these concepts of unmanned and indirect and technology driven warfare. We already see a lot of robots and drones in the war zone. They are already there. Autonomous weapon systems, almost all major forces now they are developing, both lethal and non-lethal. So, if you look at the global picture, the mobile robot, military robotics and autonomous system, they are being used in different war zones to enhance the operational capabilities, reduce human cognitive load and fatigue, to reduce risk to injury by increasing the standoff distance, to improve the situational awareness, and in general to improve or enable efficacy, velocity and the scalability. So, that is the overall aim of this military robotics and autonomous system. Next slide. Just for understanding, we can categorize these systems in different ways. We can, based on the platform types, you can have aerial, ground, water, you can have single agent, multi agent, you can have swarm. So, all kind of configurations are possible. You can define based on autonomy, level of autonomy. So, as we all know, level 1 to level 5 is generally what has been already defined. So, everybody tries to aspire to create systems which are at level 5, which is basically you are defining some mission and then the system is able to autonomously complete that mission without any human intervention. Of course, right now if you see the autonomous, the driving system, they are at level 2, level 3. So, everybody is trying to reach there to level 5. Based on operations, we can have 4 broad category of operations. So, ISR, we all know that most of these unmanned systems, they all started for this particular purpose. Then people have started using for the logistic support. So, the aerial platform, the ground platform, they can be used for the logistic support. We have systems with the guns and all for the combat support, and the systems for the combat engineering tasks in order to clear the debris, in order to for disaster management and other activities. So, these are the 4 broad categories of operation. If you look at the global picture, there are some focus areas where people have been working. So, autonomous weapon system is one where people are working on weaponized drones and loitering munitions, unmanned ground, air and sea vehicles or sea surface vehicle, man unmanned teaming. Everybody talked about here about that man unmanned teaming. So, US Air Force has a big program on collaborative combat aircraft program. Apart from that, there are a lot of challenges which people are trying to address. So, when in any mission, if there are 2 humans, they talk to each other in certain ways. If they have to communicate to the machines, there has to be some common language in which both can understand. So, the human understand languages in certain ways, the machines have to understand in the same language. So, when we talk about man unmanned teaming, those representational aspect, when someone refers to some object like say vehicle or gun or anything in the scene, then the human understand easily. Now, the machine have to understand that in the same way. So, that representational aspect has to be addressed. The multi-domain operation, that is another area where not only one type of platform, but the platform in multiple environments, they have to work together. So, that is another area where people are working. Studies on ethics, social and legal aspect, along with the fixing the responsibility of the autonomous system, that is another area in which the studies are currently ongoing. Lot of work on simulation, because the NVIDIA, I think we saw a good example of simulators. So, simulator are going to play a very important role if we really want to create autonomous system, because it is not possible to put those systems in the real world and learn there. So, it is always better to learn in the simulation and then apply in the real environment. So, that is one of the challenge that lot of places the work is ongoing. So, if you look at the major power in the world, Major General Mann also mentioned about different countries. So, China, as he mentioned, is going from informatized warfare to intelligentized warfare, where this autonomous system will play a lot of important role. US is working on this 3rd and 4th offset strategies to overcome the challenges which are posed by Russia and China. which basically includes these advanced technologies, areas of robotics, AI, and autonomy. In Europe, both EU and UK, they are all working on different programs on these military robotics. Russia is one of their popular program is to create fully robotized unit which will be capable of independent military operations. So that is something big which they are aiming into. So in US, if you see, there are multiple players which like so they have the national labs like ARL, NRL, AFRL who are working on low TRL problems. Then there are DARPA, which is basically addressing futuristic technology through industry, and they have the large, very large industrial base which are working on these problems. So this slide just captures one, I mean ARL, because we have worked with ARL, so it captures kind of their strategy, how they are looking into deploying these systems in the field in the next 10 to 15 years. So this is one of the popular program by EU. Already one version has been completed. It is called as Integrated Modular Unmanned Ground System, where they have in last 3 years they have demonstrated various capabilities in terms of man-unmanned teaming, swarming, heterogeneous technologies, cyber defense, and in December 2023 this program has been completed. So now they have gone to the next version of this, which they are trying to complete by 2028, which will be called IMAX 2. So in the previous one, 8 different EU countries participated. Now in this program, 14 different countries will be participating. Yeah, next. Similarly, UK has got a lot of systems already in place. So just few slides on what we have been doing at CARE, which is part of Center for AI and Robotics, part of DRDO. So in last 20 years, we have been working on this problem of robotics and AI. So initially, if you see around this 20th century, 21st century, we have been working on mainly manipulator arm, where we deployed a couple of systems for the military for the nuclear application, the NPCIL. Then in 2005 onwards, we have been working on mobile robotics. And recently, if you see, we have been working on creating that autonomous tank and autonomous underwater vehicle, and some work on the multi-agent and the swarming kind of application. So these are some of the prototype system which we developed in CARE. So one of them is the autonomous BMP vehicle, which was done along with our sister lab in Chennai. We have also created this autonomous car. So these are all different vehicles which were taken outboard and then converted into drive-by-wire, and then autonomy was imported onto these systems. We also worked with US Army Research Lab in one of the project where we created this aerial platform, and we also tried to close the loop between perception and autonomy. So as part of this project, we were able to on the edge, we were able to create models and do the detection, 3D reconstruction, target tracking, trail following. So some of these technologies we addressed as part of that project. Yeah. So this is one of the example where you can fly the UAV, capture the images, and use the photogrammetry to create the 3D scene of the area, and then do the better situational awareness.
Yeah, I think we had a great discussions or the talks that we heard. I mean, luckily we had a mix of members and speakers from user side, the academia, industry, and also from our research organization. So basically, stress was definitely laid on these robotic swarms and emergent behavior to accomplish multiple missions simultaneously. I think that's very much required for the armed forces also. And also the advantages of using swarms was very in detail brought out by the user rep. And also the importance of increase in tempo and mass while reducing the risk was brought out. And also the various strategies followed in various countries of accomplishing these robotic systems in military was brought out in detail. And also definitely it was brought out that simulation was very, very important. It plays a very important role in simulating because of this complete autonomous stack that is required. And to learn it, it's not really easy to make it in real. So before that, simulation is very, very important. So the complexity of the compute required to perform such simulations was also brought out. And using AI for autonomous systems in disaster relief, the importance of that was brought out, and the research areas that have been done and which are coming in the future was also brought out. I think definitely, the tone was set for the complete, and the details were almost brought out in detail of the work done in respective organizations. And we are thankful, and we thank all the speakers for that. Thank you. Thank you for the audience.
Our thanks to Group Captain Director St. Joe's to please join us on stage. May I request Sri Raj Sharma to kindly present this memento to Mr. Jigar Hilani. I request AVM Bhatnagar to kindly present a memento to Professor D.N. Singh. Our thanks to Mr. Jay Desai.
Good afternoon. In the next 10 minutes or so, I'll briefly cover collaborative air operations, swarms, manned, unmanned teaming, and the future for these. In a constantly evolving warfare environment, the winner will be the one who knows how to make the whole greater than sum of all its parts. Collaborative air combat is the ability to increase the combat effectiveness of various platforms, be they manned fighters, UCAVs, UAVs, ISR platforms, AWACS, AEW, and CFRAs, etc., all flying in the air, by merging them so as to form a synergetic team and operate in total synergy in real time. The Air Force needs to field a credible force to deter, deny, and defeat any enemy threat. To achieve these, the Air Force needs to dominate the enemy by achieving high operational tempo, maintain op resilience and complexity, while having the ability to tolerate attrition and maintain strategic reserves of both pilots, aircrafts, and other war-waging assets. Collaborative air ops can be a solution to most of these requirements that I just covered. Development of assets to achieve collaborative air ops will need safe and secure connectivity between all elements, both on ground and in the air, through networking, artificial intelligence, big data and machine learning, to assist and perform various tasks and roles while ensuring adequate security of this data available to the commanders. Swarming is a technology wherein multiple drones, unmanned and manned machines are integrated as a single networked system to execute roles and tasks in a collaborative manner. Drones, when utilized in swarms, are a low-cost, high-impact technology that will create disproportionate effort in a conflict. Besides augmenting survivability of manned assets, the swarm themselves can provide a shock and awe effect due to their inherent characteristics of low detectability, ability to overwhelm enemy defenses, and carry out precision attacks on enemy targets. They give the field commander the flexibility to utilize different mission-specific payloads and sensors. Flying in various formations, these can be utilized to deceive enemy sensors and increase his fog of war. Multi-use and multi-purpose drones working in unison in a swarm provide multi-use options to the commander. Enabled with AI and machine learning capabilities, they can be utilized for ISR, target location and identification, weapon to target matching, and target engagement to achieve the desired level of destruction from a single swarm entity. To achieve these complex tasks, AI and secure communication will be a must. Overall, swarms will reduce the sensor to shooter time during conflicts. MUMT, manned unmanned teaming, is the operation of manned and unmanned assets in a concert towards a shared mission objective. MUMT provides benefits across various missions, roles and tasks, including the dull, dirty and dangerous missions of ISR, SEAD, suppression of enemy air defenses, DEAD, destruction of enemy air defenses, protection of own assets both in ground and in air, deterrence, weapon augmentation, and search and rescue both during peace and war. Besides enhancing efficiency and effectiveness of missions, these function as a force multiplier during conflicts. The ability to take on high-risk missions through teaming ensures pilot and manned aircraft safety, especially in dense AD environments, which will be the future. Data collected through unmanned members, sensors, is available to other platforms and ground monitoring agencies, thereby improving situational awareness across all platforms and commanders. Once again, like the swarms, the MUMT will aid in reducing sensor to shooter time. Before I move on to the future of MUMT and swarms and collaborative air ops, I will briefly cover the Meher Baba competition. This was conducted by the IAF between 2018 to 2021 in 4 phases. 20 teams were finally selected for phase 2, that is the flying and technological evaluation, in which 10 drones in a swarm were to be flown in a GPS-enabled environment for a distance of 5 kilometers each way, carrying a 1 kg payload, and utilize AI to identify moving and static survivors for search and rescue operations. The final phase, the phase 3, was flown both during day and night, and in a GPS-enabled and denied environment by the swarm drones. At the end of the competition, technology has been proven with multiple indigenous alternatives available within the country. A busy slide shows the future of collaborative air operations. It shows the manned aircraft in top corner below the satellites, the networking between the unmanned decoys, UCAVs, the high altitude pseudo satellites marked in F, the satellite itself marked in M, and all these working together to achieve the mission of targeting and target destruction. So what is the need for tomorrow? There is a need to create teaming concepts that will maximize the strengths of both the CCAV, that is the collaborative combat aerial vehicles, and piloted aircrafts. There is a need to include the operators in the development of these CCAVs to ensure that the operator understands how they operate and will perform in battle space during conflicts. The war fighters themselves, that is we in the defense forces, must be able to depend on their autonomy provided and have assured control over this autonomy during conflicts and highly dynamic operations. Most important thing, during manned-unmanned teaming, the human workload is not to increase significantly. We have to find solutions so that the human workload remains within capability of the manned platforms. The defense forces themselves need to develop operational concepts of employment and tactics, techniques and procedures to exploit manned-unmanned team strengths. Lastly, but not the least, is to build mastery through continual training and testing. I just listed some of the manned-unmanned teaming and collaborative air vehicles under development across the globe from varied nations, starting from Turkey, US, EU, and lastly, but not the least, India itself. I will leave you with the last quote. How the CCAVs will collaboratively interact and operate with humans must be weighed, trained, and built into their hardware and algorithm designs from the very beginning. They cannot be formed as an afterthought. Warfighters must be involved in their creation and iterative development. Thank you.
The scope of my presentation I had actually prepared covering evolution of autonomous vehicles, design criteria, rise of autonomous vehicle, AVs in defense, roadmap of the Indian Navy, and some challenges. Basically, the autonomous vehicle have the origin in science fiction, which we all read in our comics. in World War II, remote control vehicles were very extensively used, and they laid the foundation for what we know as autonomous vehicles today. In the 1960s, Stanford University made a foray by developing the Stanford Cart. This used sensors and computers to navigate in a controlled environment. In the 2000s, DARPA came up with a lot of grand challenges which actually motivated a lot of small companies and individuals and spurred innovation in this field. And then we saw the Google car, which came up as a self-driven project in 2009. And subsequently, Tesla, as we know it, came up with the autopilot feature. Now, what do all these have in common? That is, the advancement in sensor technology, artificial intelligence, and machine learning has been the critical factor which has driven this field. The design of autonomous vehicle involves a comprehensive cross-disciplinary approach that encompasses various fields like robotics, computer science, automotive engineering, and human-computer interaction. The first and foremost in this is mission-specific adaptability that includes the ability of these AVs to work in diverse terrains, weather conditions, and operating scenarios. The second thing which is very important for the armed forces is stealth and low signature, so that the autonomous vehicles maintain a stealth and low signature in all domains in which they are going to operate in. The communication protocol which we implement for AVs must be specific, which we use. It should not happen that an enemy is able to take over an AV and land it in his place. Like when you have a kite, you should be able to control your own kite and get the kite back after you carry out your operations. Interoperability is an essential requirement of AVs. That means if an autonomous vehicle is designed by you, it must be supportable using the communication infrastructure which you already have, or your software-defined radios which you have already procured and the waveforms you have developed. The same waveform which you are using for your use currently must be adaptable and usable with your AVs also. Safety is another very important factor, and redundant sensors and control systems are often integrated to enhance this feature. Designing effective human-machine interface is another crucial factor for AV design. Therefore, what we find is the AVs have found a lot of places where we can do it. We use in various applications like subsurface, surface, that's in the marine side, surface over land, which is already going to be covered separately, and the air domain. All these are found places where the autonomous vehicles have found usage. AVs and AI and ML plays a pivotal role in development and functioning of autonomous vehicle. The key role are in perception and sensor fusion, using analytics of data from various sensors and subsequent classification of the objects. Optimal paths, considering the environmental factor and potential navigation risks, can be generated by artificial intelligence and hence assist in path planning and decision making. Machine learning also enables autonomous systems to learn and adapt to the changing environment by continuous learning and behavioral prediction. Further, artificial intelligence assists in training of the autonomous vehicles through simulation of various navigational scenarios and also improves their robustness. AI algorithms are increasingly implemented at the edge to process data real time, thus reducing the load on the communication system to backhaul all the data back. Government and non-government organizations are currently working towards bringing the autonomous vessels within the existing international legal framework, while IMO has defined regulatory framework for autonomous surface vessels as depicted on the slide. You have autonomous levels starting from 1 to complete autonomy, which is in level 4. Though in the surface side there is a level 5, in the marine side there is only level 1 to 4 which is existing. And they fall under the ambit of UNCLOS, that is United Nations Convention for Law of Sea, ratified by more than 168 partners. But underwater unmanned vehicles, we don't have any such rules. And this is an area where, as in India, we need to be proactive in formulating these regulations from our side. As technology advances continuously to redefine the nature of warfare, nations around the world are increasingly turning towards autonomous systems. Let me just touch upon two of these programs which are from the international side. First one is the DARPA program, which is Anti-Submarine Warfare Continuous Train Unmanned Vehicle. This also doesn't require any human intervention. It's used for anti-submarine warfare. Next is the Boeing Echo Voyager, a similar unmanned vessel which is used, no human intervention required, consists of, you can put in various types of sensors to operate this platform. The capability induction plan for Indian Navy emphasizes on research and development, and accordingly, IN has collaborated with academia and public sector units for design and development of autonomous vessels. We at WESI are also making significant progress in this domain. IN has already inducted anti-submarine warfare gliders, autonomous surface vessels for mine countermeasure and ASW anti-submarine warfare roles. Further development of high-endurance autonomous underwater vehicles is in an advanced stage in the Navy. The future induction focuses on swarm drones, autonomous weaponized swarm drones, to name a few. So from ASVs, AUVs, loitering munitions, remotely piloted aircrafts, AAVs, and AVs for sub-operations are the things which the Navy is looking into. We are actively collaborating with the Indian industry to develop these vehicles which are there. I've already covered ASW waveguiders. We have already inducted. High-endurance autonomous vehicle are something we are seriously looking upon, and the future project is the swarms of AUVs and autonomous vehicles. Next. On INS Makar, we already have AUVs which have already been inducted in 2012, and as you can see, the red object which is floating in the water, it does underwater mapping and environment monitoring. This is an older generation system which is there. This is an AFIB which we have developed jointly between Bharat Electronics and VESI. This is an autonomous fast intercept boat. It has achieved level 4 autonomy. It has done multiple missions between Karwar and Goa. We intend shortly to sail it in autonomous mode from Goa to Mumbai. And presently it has been used for detecting mines, that is a cloise which is floating behind. It will make the mine blast by going over it. Micro AUV is another project which in VESI we are pursuing. We are aiming it to get an endurance of around 7 to 9 hours with a length of 2.5 meters, multi-role AUV, mine sweeping and as an expendable underwater target. This also we are developing along with Bharat Electronics and other startups which are there. Sir. We have made a floor drone for surveillance, which we are currently testing in our island territory in Port Blair. This has got an AIS inbuilt into it so that it can monitor the perimeter security of the islands. We have already tested in some of the naval bases before taking it there. We are also in the process of developing a sea drone, which is a low freeboard ASV, length of around 5 meters, endurance 8 hours, sensors are electro-optical, IR, and sonar. These are some of the projects which are currently being pursued by the Indian industry and DRDO. You'll get the details about it on the internet. There are enough material available on them. So I'll just put the pictures of the projects which are currently going up. Now, what are the challenges which are there when we are operating these things, especially in the underwater domain? The foremost is the limited communication bandwidth, multipath propagation, and high attenuation. Underwater navigation without GPS also poses a threat to reliable and safe operations. Underwater vehicles typically rely on batteries, and energy storage remains a limiting factor for their endurance and operational range. Developing advanced sensors for accurate data collection in complex underwater environment is a significant challenge. Enhancing the perception capabilities of UUVs, including object recognition and environmental monitoring, is crucial for various applications. Development and deployment of underwater platforms can be it's a very expensive area to get into. It's not so cheap that you just pick up something which is commercially available, sir. Therefore, it has to be noted that the future of autonomous platforms in the underwater domain is one area there is going to be a huge amount of growth, and we are expecting the growth of around 16% till around 2030. This is from the information which is available on the internet. We also collaborate in VESI with IIT Delhi, and we have set up a technology research park. In the technology research park at IIT Hyderabad, we have got some 1,600 square feet area. We request the industry, they can collaborate with us in VESI or with NICAI. They can come and work with us in these facilities which are available. There is enough area available, and we'll provide the funding and the necessary collaboration with Navy in these places, sir. Budget is something which is very important, which has to be factored when we are getting into the autonomous areas. Therefore, with that, I finish my talk with a quote. In the era of autonomous vehicles, the road to the future is paved with innovation and driven by intelligence. We should not regret, as Shimon Peres has said, I do not regret my dreams, but I regret not dreaming enough. So we have to dream enough, and especially in the autonomous field, we have enough expertise available in the Indian industry which we can gather and integrate and develop the next product. Thank you, sir.